Welcome, everyone. Welcome to this special webinar event in collaboration with Pendulum and Fullscript. I'm Amy Regan from Fullscript, and I'm so glad that you joined us today. A few housekeeping notes. Please place all questions you have in the Q&A box for a chance for them to be answered. This webinar is being recorded, and the recording will be sent via email to all attendees and registrants, also available at fullscript.com/webinars a few days after the event. There is a copy of the presentation slides in the handout section for everybody to follow along. So today we are so excited and glad to be working with Dr. Colleen Cutcliffe, the Chief Executive Officer at Pendulum, Dr. Holly Lucille, the Senior Medical Advisor here at Fullscript, and Dr. Lara Zakaria, the Medical Advisor here at Fullscript. So welcome, everybody.
Yay.
Thank you. Excited.
Disclaimer here, and I believe Holly's going to take us away.
All right. Thank you, Amy, so much. And thank you, all of you, for being here. We have a lot to get through in this next hour. So just a little roadmap of where we're going. We're going to talk about women's health and the gut microbiome, the gut microbiome's role in estrogen-related conditions. Yes, there is a connection. The gut microbiota for therapeutic modulation, metabolism in women's health, probiotic strains and food cravings. We're going to go through a couple very interesting case studies, and then also supporting healthy weight and metabolic health with Fullscript. And then, of course, you have the ability to ask those questions. If we feel like we can get to some through the presentation, we will do that. And if not, we are going to have a very robust Q&A. And then if we can't get through everything, we will make sure you get your questions answered. So women's health and the gut microbiome. I'm going to pause for just a moment here because we're going to do a little poll. So I just want you to take about 20 seconds, read the slides, make sure you answer those questions, and then we'll keep moving on. As I said, we've got a lot to get to, and it's such great information. All right, so go ahead and take a look at that poll, click your answers, and then we'll move on. All right, so the microbiome, it really influences many areas of women's health. We're thinking about cravings, which we're going to talk about, a very complex condition that's sometimes, diagnosed or underdiagnosed or maybe overdiagnosed, PCOS, pregnancy, menopause, perimenopause, breast, cervical, and ovarian cancer, those estrogen-related conditions that we're going to talk about, and also metabolism, right? Talking a lot about metabolism clinically lately and metabolic syndrome and metabolic health and what that really means. Do we think about the microbiome? Do we think about probiotics? Maybe not, but we're going to start, okay? So, the gut microbiome opportunities throughout life. One of the things that I started probably about a decade ago, and I think I need to really talk to this. I graduated naturopathic medical school in early 2001. And throughout my entire training, I can probably count on all fingers and toes how many times the word microbiome came up or the word probiotics came up, okay? So in the last 20 plus years, the amount of research and robust research on both of those things has blown me away and helped me be a better clinician. Two of the questions that I always ask people are, when they were born, was it through your mom's vaginal canal or was it a C-section? Why? Well, we know that first inoculation to the microbiome is actually passing through your mom's vaginal canal. C-section, you get you're sterile and you get pests and you get skin bacteria. Lots of research there. So those are two questions. And then also, were you breastfed? But the health of the gut microbiome determines the path of estrogen, believe it or not. So we're looking at years and years later, right? So exposomes modulate the microbiome, and also exposure to disruptors lead to those microbial changes. And we know that we have so many of them in our modern day environment. So I am going to pass this over to my colleague, Dr. Zakaria. There you go.
Thank you so much, Holly. I am curious if just as much as not having the conversation in our respective education curriculums about the microbiome, if we talked about postbiotics or short chain fatty acids any more or any less. So I'm super curious about that conversation. Feel free to chat about it, but I have a feeling most of us didn't really cover this. So short chain fatty acids are metabolic byproducts of the microbiome. And they themselves are not so much the waste as they are kind of an upcycling of products that go back into the balance of the microbiome, but also the rebuilding of the GI lining. So when we talk about the microbiome, we're talking about not just the critters themselves and the balance that they're supposed to be in, but then the products that they then go off to make and how they help us to nurture that environment. I call them the neighborhoods of where the various bacteria, well, I should say microbiome in general, because it's not just bacteria, then apply and do and make all the things so that we can have that mucosal balance. When that gets disrupted, so not only are we seeing dysfunctions in the microbiome, we're going to see disruptions in the mucosal lining, right? And that's where we start to see what we call hyperpermeability, intestinal permeability, or leaky gut, okay? Hang tight, because this slide feels a little overwhelming. There's a lot going on here. And for my biochemistry, physiology nerds out there, pause on this slide, dive into it all you want. But here's the real takeaway for me from this slide. There's a lot of factors that play into what's happening on this stage, okay? There's multiple mechanisms that the interaction between your microbiome, what's coming into the GI, what they're doing with that stuff that's coming in there, the psychological and the physiological stuff that's happening all around there that's impacting this conversation. But ultimately, this complex mechanism is going to have 4 takeaways. We're going to impact the immune balance on a both surface level locally as well as systemic changes in terms of immune balance. We're going to change the GI barrier integrity. We can make that be positive, but certainly when it's left unchecked, it could potentially cause damage and disruption to that barrier. And ultimately, it's going to impact metabolism, and that's going to show up in terms of weight management and blood sugar control. And most of my patients, although I have very savvy patients that come to me, they've heard about intestinal permeability, leaky gut, they understand the basics of the microbiome. They're not coming to me and saying, hey, doc, I think my gut barrier function is off. Like, can we work on that, right? They're coming to me with symptoms that they're frustrated with their metabolic function. They're frustrated with the weight that's all of a sudden hard for them to shake off. They're frustrated with their blood sugar slowly going up and their doctor's warning them that they're either pre-diabetic or diabetic at this point. And it's our job as the clinicians to make those connections for them. So to understand where we can then apply a practical solution, when it's clinically relevant to apply these solutions, and ultimately how to apply it from a whole person root cause approach. So going back to layering in what Dr. Holly was saying, yes, hormonal function is going to change over the course of our lifetime. As women, we know that women are going to change, whether it is due to a hysterectomy, whether it's due to hormonal changes, natural changes over the course of time, perimenopause, menopause. Those hormones are going to fluctuate. And we can absolutely think of that. It's a normal part of the process, but ultimately that needs to also be layered on top of a picture that looks at gut health, that understands the microbiome environment and how that is going to impact those hormonal changes. And ultimately, as we think about the shift over the course of time, we then want to also think about how we approach it. HRT is one option. We absolutely can think of HRT as a way to manage these symptoms, but also remember that underneath that, how HRT is going to impact outcomes is not going to just be about hormone levels. It's going to impact long-term effects such as cardiovascular risk, cognitive health, in addition to those symptoms. So think about the symptoms, think about how we're using HRT to manage those, but let's also think about the impact of the microbiome on both the application of the HRT and then how HRT ultimately is going to further enhance those outcomes.
All right.
Thank you guys so much. I just thinking about that shift over time definitely speaks to me personally, because that plummeting little area there of that curve, I am squarely in. And so as I think about being on that roller coaster plunge moment, just really looking for all the different tools that are available and expanding the tools that we can use to kind of manage through that part of our amazing lives as women. And so one of the emerging tools that we've really been looking into is the gut microbiome and its role in estrogen-related conditions. And we're going to talk today a little bit about the emerging science that's coming out here. And I just want to say that to answer your question, Dr. Holly, from earlier, or I think Dr. Laura, maybe you brought it up. When I was in training, so I have a PhD in biochemistry and molecular biology, nobody talked about the gut microbiome. I didn't know what a short chain fatty acid was. We didn't learn any of that stuff. And so this really is, when we think about it in the context of science and biology, a new emerging space. And so I'll caveat everything that I say today is that is of right now in this moment in 2024, and we continue to learn more and more about the microbiome. But what we're learning is that there is potentially a really important role for the microbiome in our hormone therapy. So it kind of all starts with this high-level diagram here on the right-hand side here. I don't know if, can you guys see my arrow, or is that just me seeing that?
It's just you.
It's just me. Okay, well, I'm just looking at my arrow by myself. Okay, we're going to start at the top here, which is where estrogen comes from. So ovaries and adrenal glands and other organs are able to secrete estrogen. It's primarily our ovaries, but there are other organs that can also secrete estrogen. And that secreted estrogen becomes part of the circulating free estrogens in our bloodstream. And so when we think about that curve, that early part where we're very high in estrogen levels, that's really what we're talking about here, these high levels of circulating estrogens. Those circulating free estrogens can have two fates. One is to go to the intestinal tract, and the other is to go to the liver. When they go to the liver, one of the things that can happen in the liver is enzymes in the liver can conjugate those estrogens. So they'll become conjugated to things like glucuronic acid or sulfates, and they then they get secreted and become conjugated estrogens. And so both free estrogens and conjugated estrogens can make their way to the intestinal tract, the gut microbiome, and they're actually recognized by the gut microbiome as two different things. So conjugated estrogens, when they get into the gut microbiome, can actually get deconjugated by a bunch of different enzymes and strains that are in our gut microbiome. And that composite of these enzymes and strains has been referred to as the estrobolome. So it's kind of a new phrase that I don't think existed very long ago. When we say estrobolome, it's just that fancy word that means like stuff in the gut microbiome that's interacting with estrogen. But one of the important parts about the estrobolome is that it can deconjugate those estrogens. And what happens when it deconjugates them is they get secreted back and they become part of that circulating estrogens in the bloodstream. So you can actually increase your levels of circulating estrogen. And that is the role of the gut microbiome when we think about the role of how much free estrogen that we have in the bloodstream and how the gut microbiome can actually regulate those amounts by deconjugating these estrogens and putting them back into circulation. And so one of the things that we know is that the gut microbiome, and specifically these strains that are involved in the estrobolome, are linked to a wide variety of diseases. And so when you have dysbiosis or dysfunction there, it's linked to things ranging from endometriosis to PCOS to obesity and metabolic syndrome, to even cancers and brain function. And the other thing you'll notice on this diagram is that those arrows are two ways. So not only does the gut microbiome impact these diseases, but these diseases can also, when you have them, impact your microbiome. And so we're going to talk a lot more today about how do we think about interventions in this space, and specifically this one in the middle, which is really targeting obesity and metabolic syndrome. And so the idea that gut dysbiosis, the imbalance in our estrogen levels, and the symptoms of perimenopausal symptoms are all tied together, sort of diagrammed in this slide. And these two-way arrows sort of indicate that they're all influencing each other. And so how do we think about stepping into any of these and influencing these different arrows? That's really, I think, the discussion and the discovery that's happening as we speak. So if we go back to that transition slide that Dr. Lara showed earlier, the one that makes me feel scared. By the way, this slide is so funny to me because I feel like, the late 40s and early 50s, if you're in that area and you feel like you're going nuts, you are going nuts. I mean, when I look at this estradiol level going up and down in that little area, I feel like, oh my gosh, that's me. That's why I'm going crazy.
I think we call it puberty in reverse.
Yes, puberty in reverse. Exactly. Like I am going crazy. These hormones are changing everything.
And it's not just this drastic drop, right? Like it's the up and down of it. It's the constant fluctuation that also makes you feel extra crazy. Like I'm fine today, but yesterday, what was going on?
Totally. And I know when I see this like up and down of that figure, it immediately spoke to me. I was like, that's how I feel day to day. Yes. But one of the really cool things that's emerged is that as we go through this transition of having high levels of estradiol and progesterone in premenopause to then this change period during menopause to then having low levels of those hormones during postmenopause, our gut microbiome is literally mirroring what's happening with our hormones. And so when we are in our premenopausal state, we actually have on the bottom there, this in sort of shaded in blue, we actually have really high gut microbiome diversity and high potential with our estrobolome. So lots of these strains that are involved in interacting with estrogen. And over time, as we go through this menopausal transition and get into postmenopause, we start to get into this more pink area. So there's three things I want to point out that change from premenopause to postmenopause when it comes to the microbiome. The first thing is that our microbiome actually starts to look more like men. We'll get into that in a second. The second thing is that we really lose a significant amount of our diversity. So when you go through menopause, you're losing diversity of your microbiome. And that's important because the diversity of the microbiome means diversity of function. So you're actually losing functions in your microbiome as you go through menopause. And the third thing is if you start to double click into what are some of the things that you're losing in that diversity, what are some of the functions you're losing, one of the specific species that you're losing is Akkermansia muciniphila. And we're going to dig a little bit more, or maybe a lot more, into why is Akkermansia meaningful. But at a very high level, when you start to lose Akkermansia muciniphila, you lose gut barrier integrity and you increase inflammation. And so it's a really important species and set of strains that we're going to get into. But we get back to this thing about starting to look more like men. This is a study that was done in over 2,000 people where they looked at women who were premenopausal, postmenopausal, and men. And it's actually been quite widely studied that one of the biggest indicators or markers of your microbiome is actually whether you're a man or a woman. And so you can literally look at a microbiome and what's in there and almost distinguish, is this coming from a man or is this coming from a woman? And if you look at that top plot there on the far left, that big bar, that's the bar that says the sex effect, how much being a man or woman affects your microbiome. And then you see a little short bar next to it is what happens after you go through menopause. That difference is significantly diminished. So all of a sudden, the microbiomes between men and women starts to look diminished. We actually look like men in terms of our microbiome. So when we go through menopause, when you go from the premenopausal to the postmenopausal state, we have less diverse microbiomes. We look more similar to men, and that's very much linked to the fact that we have less of these microbes that are there just to interact with our estrogen levels. So we have lower estrobolome potential. And then most people know, although I'm not a clinician, and so it sort of was eye-opening for me to learn that when we go through menopause, we actually become susceptible to so many different diseases, especially around our cardiometabolic health. And so this becomes a really important thing for us to be able to target through the gut microbiome. And of all the different things that I'm about to kind of go into, the thing that I think has been probably the most well-studied, even though it's still in its nascent stages, is the role of the microbiome with metabolism. And specifically here, we're talking about type 2 diabetes. And so one of the things that we know is that as we go through menopause, the postmenopausal microbiome is deficient or depleted in some specific things. And on the top right here, you can see included in that list of deficiencies is a reduction in Bacteroides, a reduction in Bifidobacterium, a reduction in Akkermansia, and a reduction in our butyrate producers. And those reductions are all correlated to metabolic syndrome and type 2 diabetes, namely issues with BMI, our ability to metabolize glucose, and our insulin sensitivity. And that those are not just correlative, but we're going to show you here today is evidence that we can actually intervene in the microbiome and actually help with those clinical outcomes, which is a super exciting time for us to be in here today. Beyond type 2 diabetes, there's also some emerging work around skeletal muscle mass. And we all know that this is super important, not just to have strong muscle mass, but also the role that that plays in having support for our bones. And so one of the things that's been discovered is that there is a correlation between that reduction, that loss in diversity that we have as we go through menopause, and the reduction in our ability to maintain strong skeletal muscle mass. And so in this study that's being highlighted here, they looked at almost 500 healthy menopausal women. And they show that even among healthy women, there is a spectrum of your skeletal muscle mass, and that people who had strong skeletal muscle mass had high levels of Akkermansia, Clostridium, Faecobacterium prausnitzii, and Bifidobacterium verosa. And that people who had low levels of those strains actually had a lower or actually an increase in skeletal muscle mass loss, or lower amounts of skeletal muscle mass. And so as they think about the important role of muscle mass as we go through menopause, we now understand that the butyrate producers in our gut microbiome, and having more of those, can really help us potentially with muscle mass loss. And again, these are all correlative studies. And so there hasn't been an intervention study that I know of to date that's really shown that if you can increase butyrate producers, you get better skeletal muscle. But this is correlative studies that are the first indicator that if you're low in them, you're having more muscle loss. And then the last indication that we'll talk about here is really PCOS and insulin resistance. And so there have been quite a few studies really linking the gut microbiome with insulin resistance and the ability to intervene on the microbiome and reduce insulin resistance. There have been far fewer studies on PCOS, but hopefully more and more of those will continue to emerge as people realize how important this is. But some of the early studies have shown this correlation between the loss of your diversity and loss of Akkermansia and loss of butyrate producers being associated with PCOS. And so I'm, I think, very excited and confident that we will start to see studies coming out where people are trying to intervene and show outcomes in PCOS.
Dr. Colleen, can I ask a question? It's here, and I think it would be an appropriate the question is why and or how, I guess the mechanism of action is diversity loss when in menopause. Like, what is that about?
Yeah, so that's a great question. So when we're young, we have pretty diverse gut microbiomes and they have a lot of functions. There are a wide variety of things that can cause us to lose diversity in our microbiome. One of the most impactful ways to lose diversity is to take an antibiotic. But other things that really influence our gut microbiome are our diet. Many people might observe that as they're going through menopause, their food cravings start to change and the kind of foods that they're eating start to change. And so your diet is one of the ways, if you start to have a narrow diet, or you start to feel like you have food allergies, or you're sensitive to other foods, as you narrow your diet diversity, it actually narrows your microbiome diversity. But there are other things that also reduce our diversity. We just know that as we age, we start to lose diversity. We know that when we go through periods of intense stress, we lose diversity. We know that when we travel and our circadian rhythm gets disrupted, we lose diversity. And we also know that these hormonal changes, they themselves can also impact and reduce the diversity. So exactly how that happens is not entirely known. We just know that there are these correlations, but certainly the reduction of the diversity of your diet and the different kinds of foods that you're eating will result in a loss of diversity of the microbiome. So hopefully that helped.
That's perfect. Thank you.
Okay, so now the exciting part. What can we do about all this bad news here? So good to have a little bit of good news here. And we're going to start with kind of revisiting that gut lining image that Dr. Lara showed earlier. But she talked about it a little much more from a clinical standpoint, which is her background. And I'm going to talk about a little bit more from the biochemical standpoint. Really, one of the most important things that our gut microbiome does is maintain this healthy gut lining. And the strain that has really emerged as a keystone strain in your gut lining is Akkermansia muciniphila. So if we look on the left-hand side here, and we focus on a healthy microbiome, Akkermansia is that little blue guy with little spikes coming out of him. That's the cartoon representation of Akkermansia. Akkermansia does a few really important things when it comes to our gut lining. Actually in our metabolism, which is what's shown here. So when it comes to our gut lining, Akkermansia does this really interesting thing, which is that it consumes the mucin layer. So it actually feeds up the mucin layer and reduces it. But it also stimulates goblet cells to produce new mucin. And so I think about this like a wooden fence. I have a wooden fence in my backyard. And when we first moved in, it has all these wooden planks that are held together by glue. It was shiny and new and awesome. But what can happen over time with your wooden fence in the backyard through weather and just aging is that glue can start to thin, those planks can start to weaken. And if a plank falls, now all of a sudden you've got a hole in your fence. Your gut microbiome and your lining structurally is literally the same thing. When you look at these brown cells here, those are your planks, and the mucin, which is represented in blue, is your glue. And so what Akkermansia does is it literally lives at that fence. And what it does is to strip away the old glue when it gets old and put up new glue so that you can maintain this really strong fence and these planks can stay close together and have these so-called tight junctions. And so that's a really important part of our health. When you don't have the strong gut lining, as Dr. Lara was talking about earlier, there are all these negative outcomes associated with what's kind of sometimes referred to as leaky gut, where you have increased inflammation. But really at the heart of it, what's happening is you don't have these strong planks. A plank has fallen, and now all the things in your yard are going into your neighbor's yard, and all things in your neighbor's yard are coming to your yard. It's just a hot mess. Nobody likes that. You want to have a strong fence. And so that is one of the really important roles of Akkermansia. The other really important role of Akkermansia is that there are three different things that it does to stimulate GLP-1, which many people now probably are quite familiar with the GLP-1 hormone, even though it was kind of a no-name hormone, even just 2 years ago. But what Akkermansia does is three things. The first thing is that Akkermansia secretes propionate. This is a short-chain fatty acid that can get converted into butyrate that then binds to G protein coupled receptors on these L cells. L cells basically house GLP-1 inside of them, and they're waiting for a signal to release that GLP-1. So when butyrate binds to the L cells, it stimulates the release of GLP-1 from these L cells, and then that GLP-1 goes into your circulation. Akkermansia also secretes a protein called P9, and P9 can bind to these ICAM2 receptors on L cells and also stimulate them to release GLP-1. And then thirdly, which was on Lara's earlier diagram, but not this one, there's also a surface protein on Akkermansia called AMUC 1100, and it can also stimulate the release of GLP-1. So Akkermansia has these multiple ways in which it is telling these L cells it's time to release GLP-1. And as we all now know, that's really important for not only blood glucose control, but also weight management. And if we just take 1 second here to kind of talk about, this whole GLP-1 process, many of us have heard about the GLP-1 drugs that are on the market. These are actually drugs that are meant to mimic our body's natural GLP-1 hormone. And so what is supposed to happen is when you have a meal, you eat food, you have all these trillions of microbes in your microbiome that are metabolizing that food. And when Akkermansia helps metabolize that food, as you can see here, it stimulates the release of GLP-1. And when GLP-1 is released and signaled by your microbiome to be released into the bloodstream, it not only helps your body release insulin and manage those blood glucose that has now been released by the food, but it also sends a signal to your brain to say, hey, we just ate, we're full, we don't have to keep eating. And what happens when you have a misregulated microbiome? You don't have the right amount of Akkermansia. You don't have the right amount of butyrate producers. You don't get this stimulation of GLP-1 when you eat in the way that you're supposed to. And so when you don't get that stimulation of GLP-1, what you find is, oh my gosh, I'm hungry at weird times. My body is craving things that I don't really need to be eating. And all of those food cravings, and we're going to talk a lot more about that, start to get out of whack. And so that's why it's so important to have these strains and these butyrate producers and Akkermansia to stimulate GLP-1 in this natural way that it's supposed to happen. You guys probably have a lot to say about GLP-1.
Yes, unfortunately, we've got about, 20 minutes to get through your stuff if we're going to get these questions that are coming in. So yes, we probably should have a whole another webinar on the GLP-1 because yes, we do have a lot to say, I promise.
I have so much I do want to say, but we do have some cases coming up at the end, and I think we could talk a little bit more, and we'll squeeze out this GLP-1 conversation for sure. I do want to ask you one thing, and just because I think it might be on the back of some clinicians' heads, especially if you are using stool testing and you're looking at Akkermansia levels. Can you highlight for us that kind of critical balance when it comes to Akkermansia? Because I think there's concerns that elevated amounts of Akkermansia could signal that also could be more inflammation and that's calling on the gut to do some repair. Is there a balance? What do we know about it? Can you just color that in for us?
Love it.
Absolutely. Absolutely. And I think the first thing to say is that if you are a clinician, a practitioner who's using gut microbiome testing and you're using it as one piece of data paired with all this other information that you have around a patient, I think that's awesome. I think the consumer gut microbiome testing makes me nervous because if people are using that one little piece of information and they're trying to like do all this stuff with it, I think that's not actually the right way to think about your health, because this is one data point. And there are a lot of issues with those gut microbiome tests that I think practitioners are probably a lot more aware of than just kind of your everyday average consumer, and myself included. And so I feel like that's important to know. There's no standardized testing protocols. There are no standardized controls. There are no standardized levels that have been approved by the FDA. So when you get a test back and it says high or low, you really need to understand all the other things about the patient to know what to do with that information. We also now know there's an awesome publication that came out recently, I think it might have been in Nature, showing that the time of day that you happen to generate that stool can totally impact the amount of these different strains that show up in that test. So actually, if you want to do the testing the right way, what you really want is for this person to take multiple tests on subsequent days and pull all that information together to say, what are the patterns and where are things off? Because random things can change that. And non-random things can change that. So like if you decided last night I was going to eat Thai food for the first time, guess what? Day 2, your microbiome is going to look pretty different. And you might be experiencing that from symptoms. But, I think that, so I'll give all the caveats around the gut microbiome testing and what those results really mean, because I think that at the heart of it, if your test isn't totally accurate, you don't really know what to do with that data. But the second part of this, which is to say that there have been some very well-controlled studies looking at high levels of Akkermansia. The vast majority of studies that are out there have shown that low levels of Akkermansia are associated with a wide variety of diseases, probably mostly linked to this gut lining stuff that we've been talking about. But there are a few studies that have shown that there are high levels of Akkermansia correlated with different diseases, including some autoimmune diseases like multiple sclerosis. And those are super interesting because one of the theories that's coming out is that there might be some compensatory mechanism that's happening in your body that is elevating these levels of these strains in order for them to go combat it. So you can kind of think of it almost like inflammatory markers, where these high levels of inflammatory markers are telling you this person's having an issue, but those inflammation molecules are actually helping you to reduce the inflammation. And so that's one of the theories. I think we are still very much TBD on whether that's true or whether the higher levels of Akkermansia are causing diseases. And there have been no real human studies done in this. There have been a couple of animal studies, and I'll just tell you 2 because they give you the exact opposite results. There is a study that was done in UCSF here showing that if you did a microbiome transplant into animal models that have multiple sclerosis, those animals got worse. And there are a set of studies that were done at MGH, Mass General, over in Boston, of course, naturally the other side of the country, where they did microbiome transplants into mouse models that had multiple sclerosis, and they showed that it resolved the disease. There you have it. Basically, we don't know nothing.
So we still know nothing, and we're just going to keep following it and figuring it out. But what I kind of pulled away, just like from my clinical hat, is when you see that elevation, that's not a panic to say that that's potentially causing the issue. That might be a response and potentially a protective mechanism. And we should be digging a little bit deeper to understand.
Absolutely. And one other maybe data point that supports what you just said is that we know that polyphenols can increase levels of Akkermansia, and we also know that polyphenols are a good tool to combat multiple sclerosis. So it is an interesting, complicated storyline. Okay, and sorry, on the right-hand side here is like all the red bad stuff. So basically, if you're low in Akkermansia, you have this thinning mucin layer because you don't have regulation, and therefore you get the loss of these tight junctions and this leaky gut, and you also are not stimulating GLP-1. One other question that we often get, so we'll just preempt here. I don't know, I haven't been, I don't know if anybody's asked this in the Q&A yet, but there are pasteurized and live Akkermansia products out there. and so I just want to take a moment to talk about what does it mean to have a pasteurized Akkermansia. So just as a reminder, pasteurization is this awesome, amazing development invention by Louis Pasteur that where you basically heat up your thing to kill all the bacteria so that it's safer. And here in the US, we do that with milk, we do that with cheese. You're killing your bacteria. So to pasteurize Akkermansia means that you've taken live Akkermansia, you've heated it up, you've killed it, and so it releases all the innards of Akkermansia. So you can still get that surface protein AMUC 1100, you still get P9, but you're just getting the parts of it. And so what ends up happening is you can stimulate all those things that are on the left-hand side there, but you don't have then the ongoing live Akkermansia that can consume the mucin, help stimulate the new mucin layer, and then I personally, and it's not just me personally, a lot of people know that nutrition is so important when it comes to the gut microbiome. If you're taking a pasteurized Akkermansia, you're not actually capitalizing on this high fiber, high polyphenol diet, helping to stimulate Akkermansia because you don't really have live Akkermansia with the pasteurized Akkermansia. So just that little 101 on what pasteurized Akkermansia can do. A second strain that is really important in this whole storyline is Clostridium butyricum. And as butyricum suggests, it is a butyrate producer. And we know through all these different studies that one of the losses of diversity and the loss of butyrate production that's super important as we go through menopause is linked to Clostridium butyricum. And so this plays an important role in also our gut barrier. And then the third strain that's emerged as really important is Bifidobacterium infantis. This strain has actually been known for quite some time to be a really important part of our microbiome. It's actually a primary fermenter, so it produces acetate, which can be converted into butyrate, and so therefore plays a really important role in our postmenopausal microbiome. So just to get deep into one experiment here, this is the only experiment that we're going to get deep into, but I just think this one is really interesting when we think about the role of microbiome in metabolism. If you look at the top row here, this is a professor who was at Harvard at the time that he did this study. He's actually now, he's over at UCSF, but he was a student when he did this, which is pretty amazing. It's been repeated a lot of times over. What he did was he took the microbiome from an obese woman, he put it into a thin mouse, and he saw that thin mouse become obese. Then he took the microbiome from this thin woman, he put it into an obese mouse, and that obese mouse became thin. And then he took the microbiome from that thin mouse that got it from the thin woman, put it into the obese mouse from the obese woman, and that obese mouse became thin again. And the most amazing part about this study was that these two women were identical twins.
Oh, my dear.
They are genetically exactly the same. It's just their microbiomes that are changing metabolism here. And this is the first sign that, oh my gosh, regardless of your genes, your microbiome could really be playing an important role in your metabolism. And unlike your genes where you kind of get what you get and you don't throw a fit, or you throw a fit, with your microbiome, you can change it. And so this is a big opportunity to be able to modify our metabolism. And so this is a study that is kind of the first and the only of its kind showing that a probiotic formulation, when given to people with type 2 diabetes, was actually able to lower both A1C and blood glucose spikes. So this is a double-blinded, placebo-controlled, randomized trial. This is published in BMJ, and showed that compared to placebo, if we look on the right-hand side here in the top, compared to placebo, people who were taking this formulation for 12 weeks were able to lower their A1C by 0.6. And on the bottom, that's the area under the curve, the area under the blood glucose curve. It was shown in this publication that compared to placebo, pendulum glucose control, or this formulation, was able to lower blood glucose spikes, that area under the curve, by 33%. And so this is the first data point that shows that you can change your microbiome by increasing these butyrate producers, increasing your Akkermansia levels, and then getting this real clinical outcome for patients with type 2 diabetes. And then along those lines, kind of looking deeper into the mechanism of action of Clostridium butyricum, it is able to produce a secondary bile acid called UDCA. And when UDCA is produced, it helps to stimulate the production of GLP-1. And so that's one of the clear mechanisms of action of Clostridium butyricum and of butyrate. And in subsequent publications, it was shown that in these patients that had these improvements in their A1C and blood glucose spikes that were being given butyricum, Clostridium butyricum, they had increased levels of the secondary bile acid, and they also had increased levels of the strains themselves. This is a separate study, which I think is super interesting when we think about dieting. So what this group did is they took all of these people with type 2 diabetes, and they basically put them on the same diet. And it was, as you would imagine, a calorie-restricted diet, high fiber, blah, blah, blah. And as we all know, that you can put everybody on the same diet and people respond differently. And what they found was that people who responded better to the diet actually had higher starting levels of Akkermansia. So if you had more Akkermansia in your microbiome and you went on this diet, you actually had better fasting blood glucose at the end, better triglyceride levels, and better body fat distribution after going on the same diet as somebody that had low Akkermansia. They didn't have all these beneficial outcomes. And we think a lot about this when we think about the moment where somebody decides, okay, I am going to clean up my act. I'm going to eat the right foods. I'm going to exercise. And there's nothing more disheartening than to make that decision and then to not see results. So what are all the different tools that we can provide to people to help them jumpstart their journey to seeing results? And this indicates that if you could help them have Akkermansia levels that are higher, that you could help them start to see these results from their diet.
Well, and can I just also mention that very often that change in diet is a carbohydrate restriction, right? And that's going to impact their microbiome. And so very often I see them as they're restricting those carbohydrates, they're restricting sort of the diversity of those polyphenols, the fibers, and all those things are going to impact ultimately their microbiome and then, of course, their metabolic results.
Absolutely. Absolutely. And I think that being able to modify your diet and your microbiome simultaneously is like when you think about a car. If you want to have a high performing car, you got to put great fuel into it and you have to have a high performing engine under the hood. If you only have one of those, your car's not actually as high performing as it could be. And so your fuel is your nutrition and the foods that you're eating, and your engine here is your microbiome. So if you want to have your body be the highest performing vehicle it can be, you want both the great nutrition and the great engine, the great microbiome. And so tied to that, kind of how can we help people jumpstart the efficacy of their great fuel, their great nutrition, is this concept of food guilt. And oh my gosh, it blew me away when I saw this stat. 80% of women are walking around with food guilt. 80% of us are feeling guilty about the last time that we ate a brownie, the last time we chose a burger over a salad. And it's not just that moment where that decision gets made. We're walking around with that all the time. And that guilt can lead to even, this sort of bad cycle of then new poor decision making. And we know that, I mean, you don't need to be a scientist or a doctor to know that when you eat poorly, you feel poorly, and then you eat poorly, and you end up in this really bad cycle. So how can we break into that food guilt by intervening in food cravings? I think that's another big opportunity for the microbiome. And I'm going to show you data on these very specific 3 strains, Akkermansia muciniphila, Clostridium butyricum, and Bifidobacterium infantis, and what happens when you combine those strains, which actually work together to increase butyrate, to stimulate GLP-1 release, what can happen to our food cravings if we can actually deliver that to people. And it's super exciting because I'll just give you the spoiler alert, it's good. So in this study, I'll give all the big caveats, which is that this is a consumer study, open label. It's not a placebo-controlled double-blinded trial. Those studies are ongoing. But in this study, there are almost 300 people that were given this formulation of these 3 strains and asked to take up a pill every day that had these strains in it. And they were also asked to take the food cravings inventory. So this is a validated diagnostic test for food cravings. And essentially a little snippet of the test here is on the right, which you just get asked how often do you crave these different foods? And sometimes when I look at this list, it makes me hungry. But in any case, these are all foods that are on the spectrum of great for you and terrible for you. And you're just trying to look at what are people's different food cravings. And we know that there are 4 buckets of food cravings. There's sugars, carbs, high-fat foods, and fast foods, and they all then get sorted in this food cravings inventory. So what happened after people were on this formulation of these 3 strains? 91% of them had reduced food cravings after only being on this product for 6 weeks. So by increasing the levels of these 3 different strains, they're able to reduce their food cravings. And when we double click into that and you sort of bucket these people by their starting food cravings, what you can see is that baseline is in blue, and then after being on the product for 6 weeks is in purple. And if you look on the far right here, the people who start with the highest amount of food cravings actually see the biggest amount of improvement in their food cravings. And that's maybe not surprising that the more signal you have or the more dynamic range you have, the better chance you're going to see a result. But it does go to show that if you are fighting food cravings, that your microbiome might be part of the problem, and that if you just increase these microbes, you could help battle some of those food cravings. And then therefore that helps with the reduced, bad choices and the improvement in food guilt. And then moreover, as I mentioned, there's 4 different types of food cravings. There's the carbs, the fast foods, the high fats, and the sweets. And we see a lowering of food cravings across all 4 different types of cravings.
Can I pause on that idea for just a second? Because I think so much of our training in terms of like what it means to lose weight is sort of moralized around our decisions and what we are controlling ourselves and how much we're holding back. And so there's this idea that like, if you're gaining weight, there must be something inherently wrong with the decisions that you're making. And I think there's layers to this, right? I don't want to oversimplify our cravings to just what's going on in our microbiome. There's psychological reasons and joyous reasons to choose foods because they're delicious and because they're part of our culture and because they're just part of what we, want to enjoy day to day. But I think there's something so liberating about thinking about like the physiological reasons why you may not be following through on decisions that you're making in terms of your eating and how you're eating and those choices that you're making. And I think that is valuable in and of itself. I'd love to see more on this and how that drives decisions.
Laura, I couldn't agree more. And even like what Colleen said, if you get into a shame cycle about it, well, what elevates then? Well, cortisol. What does cortisol elevated over a period of time do? It continues to disrupt your microbiome. So it's not only a cycle psychologically, emotionally, it's going to be a cycle physiologically and with your microbiome.
Well said.
Oh, such a great point. And I will tell you that we have I'll tell you about one specific customer that I'll try to do without crying. This person basically said, I have been a sweet tooth all my life. Mm-hmm. I mean, that's who I am. That's me. And you put anything sugary in front of me, I'm going to be eating it. I go to the Christmas party, I'm eating all the cookies. Like, that's just who I am. And it's just me. And they went on this formulation. They were able to increase the levels of these strains in their microbiome. And all of a sudden they found that their sugar cravings were gone. And basically this person who felt that was who they were, realized that was just these microbes that were creating these signals of cravings for food they didn't really need. And when those were gone, Lara, your word liberated was so great. They essentially said, I'm not a sweet tooth. That's not me. That was my microbes. I actually can resist sweets. And it was such an amazing story about breaking free of who you think you are into who you want to be, and just that it's physiological and it's your microbiome in this particular case. So awesome.
That's awesome.
So ladies, I just want us to know we have about 13 minutes left of the presentation.
Okay.
So we're going to move on.
Okay. I'm passing
Jump into the cases. Okay, amazing. So we have 2 cases. These were the results of surveys of individuals that were given the Pendulum glucose control product and followed over 3 months. So we're going to start with our first case. I like to name my cases. This is going to be Mary. So our case 1 is going to be, we're going to call her Mary. Mary is 68 years old. She is menopausal, and she does have a diagnosis of type 2 diabetes, but this is a long-standing diagnosis. She's had that since 2002, and this was conducted in 22. She is managing it with metformin alone. She was on 2,000 milligrams per day. She also has glaucoma and hyperthyroidism. So there's a lot going on there. It looks like, now I'm looking at her med list, it looks like she was also given Zetia. So I'm already thinking liver stuff. I'm thinking dyslipidemia potentially, and she's on levothyroxine. So I'm wondering if maybe she had an ablation or something like that. And then trazodone for sleep, which we see so often. Like, she literally, Mary, could be like 30% of my patients. She looks like everybody, 68-year-old postmenopausal women, and that combination of drugs, the metabolic symptoms make a lot of sense. So she started on the glucose control, the pendulum glucose control. She also had some additional help. She had some fiber in addition to that. We know that fiber can help with blunting blood sugar. It also can support dyslipidemia. So multiple reasons why we could do that. Obviously, it's going to modulate the microbiome as well. And she was using a CGM. So 100% in range. So she was managed really well with her diet. She was on an intermittent fasting and a low carb diet plan. So it's not just the pendulum alone. We're using a whole person approach. We're approaching it from all the different angles while we also modulate that microbiome. Follow up 3 months later, she lost 4 pounds. Now that may not sound like a lot, but I know that for a lot of people, when they're just stuck at a weight and it's not nudging, a couple of pounds could be all they need to really start seeing the differences.
And feeling the difference, yes.
And feeling the difference. And I think what's really interesting is like her perception of the symptoms, reduction in blood and sugar cravings, right? Knowing that you can control those cravings a little bit more. Appetite control, not feeling like she doesn't have control over what choices she's making. And reduction in abdominal pain, which I think is so important, because notice none of her symptoms really matched. Nothing said to me like she has GI issues, right? And I see that very often in my clinic where folks come in for one symptom and all of a sudden as we dig more, there's actually some GI stuff going on. It's also worth noting that there was a decrease in her dose of metformin as a result of her improved blood sugar control. So this wasn't just her perception of it. This is actually literally an improvement in her blood sugar control. I'll pause here. Colleen, anything you want to color in? I'm really interested in that piece about the shift in the GI function. And again, how do we know when we've got this like polypharmacy type of patient, lots of metabolic stuff going on, what are we looking at that might say this is a good candidate for the glucose control formula?
I mean, I really think that anytime you're thinking that the diet is going to be a big lever, that the microbiome is going to be tied to that. I mean, just nutrition and as I said, it's really, I think about the fuel in the engine, those two things are tied. So if you think that this person's really getting no fiber in their diet, or they're hardly eating any polyphenols, that's going to be a great candidate for a microbiome intervention, because we know one of the important things that high fiber and high polyphenol diets do is increase the level of these butyrate producing strains, and Akkermansia in particular. So I mean, I'm not a clinician, and so you guys know better, like who do you think are these good candidates? But I would say anytime you're thinking that this nutrition, oh my gosh, you got to increase your fiber, and you're stepping them into it because maybe their fiber level is so low right now that nobody could possibly eat the daily dose, and sorry to be crude, but like they be in the bathroom all day long. Those people are probably good candidates for a microbiome intervention as well, and specifically glucose control.
I mean, thanks to, thankfully it's coming to my mind quicker than it used to because of all of this information and research. I actually will see tomorrow an identical twin who is 40 pounds heavier than her identical twin, who has high triglycerides, who has an A1C that's elevated, an insulin is elevated. And the only thing that we're going to work on is her microbiome, because I think we have to do that first. I call it the inertia phenomenon. Like just as it was reported in Lara's case, once they start to feel like there can be some success after all of the potential failures and tries, then they get hope. And that's when clinical outcomes start to increase. So I love it. Okay, we've got 8 minutes, so we're going to keep going on. And I want everybody to know we do have somebody answering questions. If we don't get to them verbally, you will have them answered. And I do believe that they're also going to be able to be viewed when this webinar is sent out after we are finished. So, okay, moving on.
Amazing. Okay, moving on to case number 2. We're going to call her Polly. So Polly is a 65-year-old, also menopausal woman, also with type 2 diabetes. Hers seems to be managed well. She's not on medications currently. She is not taking any other supplements, no fiber, and other than taking a probiotic yogurt, she's not really using anything to modulate her microbiome. She's also on an intermittent fasting low carb diet. diet. You'll see this a lot in this population. I know my patients are very savvy, big readers. And so they're reading a lot of the hormone like savvy books and like learning about how to use low carbohydrate diets to their advantage, particularly post-menopause. But I also think like in that assessment, when you're not seeing that they're eating a lot of fiber or polyphenols, maybe they're not navigating. I do think there's a way to do low carb and still colorful and still include a lot of fiber and low glycemic produce, but very often they're kind of gearing towards less colorful diets, let's call it that. And so I think this is, for me, the opportunity. So in her case, Polly started the Pendulum glucose control formula as well. 3 months later, lost 3 pounds. Again, no other interventions, similar diet. We don't have a CGM for her, but there were some improvements in some of her GI symptoms. Again, that piece where maybe they didn't notice it before, and now all of a sudden they're like, oh, actually, I just realized that symptom wasn't normal, and that's actually improved. Reduced sugar cravings again, better blood sugar control, and even a reduction in anxiety. I think also harking back to that connection between stress, anxiety, mental health, and how that impacts our microbiome. Any other thoughts that we want to add on Polly's case?
I know we're short on time, and but I would just add that one of the things about improving your two things. One, improving your microbiome and sort of in this natural way is that what people find is, in contrast to drugs, where oftentimes the drug is like solving one problem but creating a whole series of other random side effects. When you go through the microbiome and you're able to improve that, it's not just seeing improvements in things like A1C and fasting blood glucose, but people start to feel more side effects, like in a good way, improvements. So we hear people talk about reduced brain fog, more energy, these reduced sugar cravings, this, as you said, this, better clarity, because your microbiome does actually help reduce things like GABA, which reduces your stress, and dopamine and serotonin, all these awesome transmitters. Yeah. And so in contrast to drugs, oftentimes when you're improving someone's microbiome, you're seeing added benefits beyond just what you're targeting. And the other thing I just want to say, as in terms of when we think about weight, is that, for these folks, we're not showcasing maybe changes in weight distribution, but if you could turn 5 pounds of fat into 5 pounds of muscle, that is a huge win, and that's not going to show up on the scale. And so I just want to point that out as well. We're not seeing that part.
100%. And I also want to add that very often our focus so much is on weight, because I think that's the easiest thing for us to see. But the folks I'm working with, we're not focused. I tell them that's a side effect. If you lose weight, that's a side effect. And I don't want you necessarily to lose weight, to your point, Colleen, at the expense of losing muscle. And all those other symptoms, I think, are really valuable in helping us to understand their metabolic side effects.
And I would add, and then we're going to get to our second poll. I think outside of manipulating and managing your microbiome, one of the best metabolic things anybody can do is build muscle.
Yes.
And you're right, it's not going to show up in the scale because muscle weighs a little bit harder. Okay, I'm going to just take another 20 seconds here before I give it back to Colleen. And we have a poll for you. So just take a look at what's going on there on your slide and check the box for how we're doing. And then we're going to move on and we'll finish up. And again, this is going to get sent to you and you will also see answers to your questions. All right, Colleen, you can take it over.
Okay, great. Hopefully everyone feels like they learned some things here. I usually find that when I'm learning something, it opens up all kinds of new things that I feel like I need to learn. So if you're feeling that way, that I think we're all very pleased. But just at a high level summary, hopefully what you learned here today is that the gut microbiome is an important part of health, and especially in women's health, there's emerging evidence that it's an important target. This word estrobolome, if you hadn't heard it before today, maybe it's something that you'll see again, but it's basically all the microbes that are involved in dealing with estrogen. There are keystone strains, especially Akkermansia, muciniphila, Clostridium butyricum, and Bifidobacterium infantis, that are super important to our butyrate levels, which is really important for our gut lining, as well as our body's ability to stimulate natural GLP-1 release.
All righty. So supporting healthy weight and metabolic health with Fullscript. As you well know, Fullscript has protocols that you can actually scan right now to view this one. It was developed in collaboration with Dr. Kara Fitzgerald around supporting GLP-1 production. And there are many, many beautiful handouts on Fullscript that you can see to assist. And so, of course, we've got probiotics, prebiotic fibers, polyphenols, omega-3 fatty acids, and, of course, dietary modifications. And then, Lara, I'll have you take it over, I guess, just to share the stage.
Yeah, absolutely. So again, a reminder, we talked a lot about the species, the glucose control formula and the species, the Akkermansia species, and I think that's a great starting point. So definitely encourage you to scan this to learn more about that. But I also want to go back to the foundations that was on the last slide. Notice that it's sitting firmly on a foundation of nutrition. We are using multiple strains. I think it's a really clever way to combine all the various mechanisms. Remember, it's not a one-to-one thing here. There's multiple mechanisms involved. There's multiple factors that play in. And so really the layering of the probiotics on top of prebiotics, on top of the specific polyphenols that help to encourage not only the Akkermansia species, but as we learn from Dr. Colleen, those related species that help with the production of the short chain fatty acids and all those key players that help in modulating those mechanisms. And then I love the omega-3 fatty acids. There's all this older conversation about what omega-3s do for blood sugar control, glycemic control, insulin sensitivity, fatty liver, dyslipidemia, but we're seeing how it's also overlapping like a Venn diagram with this Akkermansia mechanism that we're talking about as well, while we're also addressing inflammation. So I really want to highlight this combination, but definitely dive in and take a look at what we could do with that probiotic species as part of this lineup.
All right. So again, we are right at 12 o'clock. Thank you so much for joining all of us. You're going to get this because I want to listen to it again and just dive in. You got these scans here to just learn more about Pendulum and Akkermansia and other novel probiotics. And then we're going to get all your questions answered as well. So given that, I just want to thank you all so much. And Amy, I'll take it back to you.
Of course. Thank you so much for everybody who joined us today. What a super dense and informational webinar. I know that everybody learned a lot. And I just want to say thank you so much to all of our presenters and sort of wrap up quickly here. Everyone take a look in their email with a link to view this recording, as well as a special offer from Pendulum. Hoping to send that on Monday just to let everybody know. Anyone who has any additional questions can send them right over to me. My email address is amy.regan, REGAN, @fullscript.com. And thank you again to everyone and enjoy the rest of your day. Thank you, team.
Thank you.